In this tutorial, we're going to talk about section 7.4, similarity in right triangles. And to start this section off, we're going to start off with a theorem. And this theorem is theorem 7.3. It's on page 392 in your textbook if you want to get a better description of it. But here I have one big right triangle, triangle ABC. I know it's a right triangle because angle B is a right angle. Now, the line BD happens to be an altitude. It connects the vertex to the opposite side at a right angle. Now, what this theorem says is actually really easy. If I have one big right triangle and the altitude is drawn, just like I have here, then it means that we have three similar triangles. I could say triangle A, B, C is similar to, and we would do triangle C, B, D is similar to triangle ABD. Now, don't worry if my letters aren't in the exact right position at this point in time. I just want you to get the concept that if you have a right triangle with an altitude, you have three similar triangles. Now, the next thing that we're going to talk about is something called a geometric mean. So, here's your definition for geometric mean. For any two positive numbers, A and B, the geometric mean of A and B is the positive number x such that this proportion is true. A over x equals x over b. Or if you cross multiplied every single time, you would find out that x is equal to the square root of A times b. Okay, that's a lot of information. Let's take a look at a little example down here at the bottom. Let's say I wanted to know the geometric mean of two numbers. We're going to do 2 and 4. Let's find the geometric mean of those two numbers. So we can have 2 represent A and 4 represent B, or vice versa. It's not going to matter. We're going to get the same exact answer. So I'm going to write 2 over x equals x over 4. And when I solve that, when I cross multiply, I get 8 is equal to x squared. Now, I don't want to know what x squared is. I want to know what x is. So to cancel to square, we square root both sides. And in this case, I would have x equals the square root of, oops, I didn't write any x, of 8, or the product of the two numbers itself. So you can set it up as a proportion if it makes you feel more comfortable, or you can jump straight to the shortcut. All right. So let's take a look at this example. It says to solve for x and y. And if you are unfamiliar with how to work with geometric mean or similarity or cross products, this is going to be really hard, but we can use our new theorems to help us out a bit. Now, I'm going to try to solve for y first because I think it's a lot easier, even though it may not seem like we really have enough information. Now, the two main triangles that I'm working with here are, or at least at first, this small triangle in blue and the medium-sized triangle in green. The larger triangle, of course, is the triangle that incorporates both of those on the outside. So the way I'm going to set up my proportion is in the small triangle, if I'm starting to solve for y, I want to keep x out of the loop here because otherwise that gives me mixed variables and that's a problem. So it looks like 4 here represents the small leg, or the short leg, and y represents the long leg. So I'm going to write this small leg over long leg. I'm going to go over to the medium-sized triangle, and I'm going to do the same exact thing. Now I started off with the short leg. Now in the green triangle, the short leg is not 5. It's going to be y. So I'm going to write y over, and now I'm going to do the long leg, which is 5. So if you notice here, this looks exactly like what that geometric mean was talking about. In order to solve for y, I can very quickly skip to that shortcut and say that y is going to be equal to the product, the square root of the product of 4 and 5. So the square root of 4 times 5 is going to be the square root of 20. And we can simplify this radical very easily. If you don't remember your simplifying radicals properties, that's okay. If you've never seen it before, that's okay too, but we're going to have to start learning how to do it. Let me show you how to break down the square root of 20 here. So I'm going to write another square root symbol, and over to the side I'm going to make a factor tree for 20. So I know that 2 times 10 gives me 20. 2 happens to be a prime number. A prime number is a number that is only divisible by 1 in itself. So 2 is a prime number. Now 10 is not, so we're going to keep breaking him down. So 2 and 5, and 2 is prime, so is 5. So I'm going to write all of those factors underneath my radical, or my square root, just like so. 2 times 2 times 5. Now, the square root, in order to simplify this, we want her to find a pair of the same number. And in this case, I have a pair of 2's. So if I have a pair of 2's, I can bring the 2 to the outside of the radical. So this goes away and comes out here. Now 5 does not have a pair, so he's going to stay under the radical. So my simplified version is 2 square roots of 5. And that is a far more accurate answer than a decimal because there is no rounding involved. Alright, so how are we going to solve for x now? Well, we can use the Pythagorean theorem if you'd like to, because in the small blue triangle I now know what y is, and I know the small leg. So we can go ahead and do that. It's going to be 4 squared plus, let's see, 2 square roots of 5 squared, I'll put that in parentheses just in case, equals x squared. Alright, so 4 squared is 16. Now, how do I square this guy? Well, you kind of want to work with them as individual parts. So let's do the 2 part first. So 2 squared is 4, and this is multiplication because up here it's multiplied. And the square root of 5 squared, well, a square root and a square cancel each other out, so that's just 5. And that equals x squared. Okay. So we have 16 plus 4 times 5, which is 20, equals x squared. All right, we're getting closer. So x squared is equal to 16 plus 20 is 36. And we square root both sides, so x is equal to the square root of 36, which is 6. So there you go, I solved for both of my variables. And some of these problems are going to prove to be a bit tricky at first, but you will get the hang of it. And that concludes this tutorial.